Ladies and gentlemen, welcome to the lecture on User Interface Engineering, Chapter 7, Usability Evaluation, and this is the second video segment. We already gave an introduction about what evaluation is, when we evaluate, and that we can differentiate empirical and analytical evaluation methods. And today in this video I would like to talk about analytical evaluation methods. So they can be used quite early already in the development process because they do not require a ready prototype, they do not require users who actually test a prototype. So before a system is built, a system can be analytically analyzed and evaluated. And therefore it's also very inexpensive, but of course it requires some expert knowledge, because not everybody can imagine how an interface would be used when ready, regardless of their previous knowledge, obviously. So we can differentiate two major methods or two major types of analytical method, and these are first of all the inspection methods and second the formal evaluation. Inspection methods is when experts look at a system. This can be, of course, a ready-made or a final system or a prototype of a system, but often it is just a system design, a conceptual system, such as described by scenarios or such as described by a user interface described by storyboards, for example. And then the formal evaluation, it's possible to have a formal description of a system design which is used to predict its future system use. What does it mean? It means you have some description of a system which is not as informal as a scenario and not as informal as, say, a storyboard, but instead it's a formal systematic description of a system design, and the more formal it is, the more you can actually let an algorithm run on that, or just to use it step by step and predict, for example, the usage times, how long it will take that a system is being used. I will illustrate that later on with the keystroke model. So let me talk about these types of analytical evaluation methods and provide some details on example methods. The inspection methods where experts are in play are often guided by usability guidelines, by recommendations, and they are described in form of a checklist. So that means experts have some previous knowledge, of course, and they have some guidance where they can look it up, or where they can just check certain aspects of a software system, of a user interface, and by these checklists they are able to evaluate how good a system most likely will be. I give you a simple example. Consistency check are, say, in all dialog boxes, the buttons such as OK and cancel, are they all placed appropriately? Are they all named in the same way? Is there internal consistency? This would be just a single example of what type of checks can be easily made before giving a system to a user, or even before building a system. And of course, it's not just a single person you would like to have. So if you can afford it, and in most cases if it is a real product, you should and can, it is more than one expert, and a couple of experts are already sufficient to find out most of the important problems a system might have. Just keep that in mind. Not the final user is testing the system, or not the intended user. It is experts. Of course, you might want to use a standardized set of tasks. Sometimes they go through an interface by imagining how it will be used for a particular task. Say, I would like to select an object. This would be a standard task. And how does my interface perform that? How will it perform on that? How good will it be? How well is it suited to be operated with or to achieve that particular selection task. And of course, it is important, perhaps you would like to have a comparison of several interfaces or of older interfaces, and if you have that, then of course you could use that kind of standard task to compare things. The critiques experts give can be formalized by any means, or they can also just be informal reports, basically. So this is basically what I do if I criticize, say, a design my PhD students do. Maybe they have designed some gestures, some interaction techniques, and my informal report tells them, okay, I think that's not so good because it's not a symmetrical action, or this gesture is too complicated, too cumbersome to do with your hands, or you have too many gestures for all the different functions, etc. Of course, you can list problems which are identified in each category, such as consistency, such as menu design, such as certain tasks, how they can be fulfilled. But sometimes it's also good to rate them in terms of how severe they actually are. So some mistakes or some flaws in the design might be just of a cosmetic nature. Say that the alignment of certain words should be improved. Or it could be minor things like spelling mistakes or so. But there are also major issues such as that the menus are totally equally balanced, for example. And maybe catastrophic error, it sounds a bit very weird, but catastrophic would be that you cannot reach a certain action at all, which however is a very important one. So that's, or a catastrophic error you could find out in an inspection method is if you say evaluate the design of an ATM to withdraw money, and then you find out there are certain situations where the user, say, does neither receive their cards back nor the money, also that would be of course a catastrophic situation. And as I said, guidelines help us often. They can be at many levels. I just talked about examples of screen layout or of dialog boxes, for example. But you could also analyze the cognitive states of a user in detail. So how complicated will it be maybe to find a hidden menu point on hierarchy level 5, for example. It involves often stepping through a pre-planned scenario and where you then note potential problems which might arise from working with that type of scenario or within this scenario's tasks. All right, let's look a little bit in more detail to the expert reviewers first. Keep in mind that's more than giving some informal demos to colleagues around the office or so, or to customers, which by the way can of course also provide useful feedback. It is more than that because you really analyze something. You sit down, like I sit down here, you look at the interface or at the description of the interface, and you really go in your mind through different criteria and really carefully analyze it. So this is a difference in just quickly doing a demo. Of course, the more formal ones often have to have proven to be more effective, obviously, and this test can be maybe just a couple of hours, or it can be even 1 week effort. So if you really go into all the details in every system description, whatever, every scenario which has been written, or every storyboard which has been drawn, then of course it might take a week. So there's a variety of expert review methods we can choose from, and this could be heuristic evaluation. This is a famous one. then a pure guidelines review, a consistency inspection. Basically, I already hinted at that, where you just go through the system and try to figure out whether it's consistent in all regards. Cognitive walkthrough or pluralistic walkthrough. Pluralistic walkthrough is just a variant of the cognitive walkthrough involving more people. And then, of course, you can even use some metaphors or concepts of human thinking and apply them. How would human beings think? And you have maybe some models, and you think about that and apply them to an interface. And finally, you can have some formal usability inspection, which really involves very long lists of items and questionnaires and everything. So I will be talking in this section about heuristic evaluation and cognitive walkthrough first. Heuristic evaluation is a method which has been developed by one of the big shots in usability engineering and in also human-computer interaction, Jakob Nielsen, in the 1990s, in the early 1990s. And he basically developed some usability heuristics we already talked about. You remember that from the previous lecture. And he distilled them from an empirical analysis of 249 usability problems. So basically, he investigated an interface in several ways and came up with this long list of problems and tried to summarize it, to abstract it into the 10 heuristics we already talked about. But of course, this is a little bit flexible. You can and should adapt the heuristics, for example, to modern current devices. Some of the heuristics are just applying to, obviously, because it was in the 1990s, to mouse and keyboard interaction, and for example, not to gestural interaction using maybe mid-air gestures. Or maybe they were applying to screens, which is the case, but not to augmented reality displays, etc. And of course, if you have different type of users, or maybe even more than one user, because a typical desktop interface is a single user interface, whereas a modern natural user interface often involves many users or a couple of users. So you have to adapt it to also the number of users, for example. So the procedure is quite clear. It's a three-stage procedure in heuristic evaluation. First of all, there's a briefing where you inspect the user interface thoroughly. Then there comes the evaluation part where you inspect it again, but now compared against heuristics, single items heuristics, and you take notes. And then there's debriefing where you try to group or even solve first the usability problems you encountered. You prioritize them. For example, you say this is an important and major problem, or this is just a minor flaw, and you suggest solutions. You can do that not just for a single expert, as I said, but for multiple experts. And it's clear here in this case they should work separately, because at the end of the day you would of course like to assemble all their opinion and hopefully maybe they agree on some mistakes and hopefully find more than what a single person could possibly find. So you compare the results during the debriefing at the end, and this could be based on scenarios, the heuristic evaluation by Jakob Nielsen. But it works on almost everything what you have maybe on sketches, on storyboards, on paper prototypes, on unstable prototypes, on real prototypes, on final systems. So it's a quite flexible method which can be used early on until later. The original heuristics, you see them again in this on this website, are described here, and of course you see they match what we talked about in an earlier design lecture. So meet the expectations. That means match the system and real world. This is something like we talked about, that you have appropriate metaphors and that my previous knowledge is being used as much as possible. In the design, consistency and standards are important, and then of course to provide help and documentation so that people are not lost using this. Then the user is the boss. That means giving the user control and freedom. For example, provide shortcuts, provide alternative ways to reach a goal, and don't force them to do exactly the steps in the right order you prescribed to them. Visibility of system status always provide feedback in the sense of where am I in the system, what is the system currently doing, why do I have to wait, do I have to wait at all, etc. And then of course flexibility and efficiency of use, that you design for efficiency, that's also important. Errors are important to consider, so you have to first try to prevent them if possible. Then of course errors are also reduced when you present the available options to the user so that they can recognize them instead of having to memorize, for example, commands in a command line language or gestures in a gesture-based interface. So you have to somehow offer these choices to the user in a form of visual menu, for example, or some icons or some explanations what to do next. Help users to recognize, diagnose, and recover from errors. That's important. So don't leave them alone and just say catastrophic error, but tell them something how to correct them and support them in that endeavor. And then of course keep it simple and nice, which again relates to especially the information design. Try to aim at an aesthetic and minimalistic design. Concerning the number of evaluators, Nielsen made an interesting observation, and he compared several numbers of evaluators basically, and found out that roughly 5 persons evaluating a system by means of heuristic evaluation are sufficient to spot and identify 75 to 80% of the built-in usability problems. Why do I say built-in usability problems? Because it doesn't tell anything about the actual usage, about problems arising during the actual usage, which might be more complex because certain states are into play. Maybe there are complicated situations, say the user is pressing 2 keys at the same time and maybe clicking on some button, and this is something you cannot predict just by looking at a sketch of the software, or not by just maybe looking at a prototype. But some like built-in or ready-made or designed usability problems, such as inconsistency in button placement, as I said earlier, can be spotted. And you see that if you just have a single evaluator, a single person, this person might only find out 30%, and then it gets so it increases obviously, but you see it doesn't make a big difference to have 10 people evaluating it or 15 people evaluating it. You see the number of errors you can find by that inspection, by this heuristic evaluation, is not really higher than with just 5. So this is a kind of trade-off to have 5 to 6 evaluators, which give you already 3/4 of all potentially designed usability problems, and that helps. So it's an expensive method, therefore, because only few people are involved. It can be, as I said, used very early in the design cycle, which is of course a big advantage, and you don't have to approve, make an ethics approval for your complex user study involving 200 people, and there are not too many practical issues to be considered, like how to design the lab for that particular experiments, because users are not involved. That's the simple reason for that. And issues, of course, it is sometimes problematic to find experts, even in our group. Also, of course, many more experienced PhD students or postdocs and me consider ourselves to be experts, and yet not everybody is available. So sometimes it's a bit problematic. The best experts ideally have not just knowledge about user interfaces, but also about the application domain, or vice versa. It would be great if, say, you design an interface for a surgeon in medicine and maybe for the operating theater, operating room, that you know a bit about medicine and user interface design. That would be great to be able to appropriately evaluate the interface. Of course, if you have experts with little experience, which maybe arguably that are not experts, then this is not very good. So if people do not have much experiences, you don't gain a lot of knowledge and a lot of issues at the end being listed. And of course, some important problems may get missed, as I said earlier, in this method of heuristic evaluation, because it's not the system is not being used actually, as I said. And often rather trivial problems are identified and are identified again and again, such as, oh, the button is maybe, the order is maybe switched between OK and cancel button in a confirmation dialog, which is a rather trivial issue, which is not really a hard thing. And the inspections do not reveal the validity of the findings. So you don't really know whether they actually apply in a situation, whether they are important in a given situation later on, because the system has not been used yet, which is the only way to actually do empirical evaluation, where you then find out whether this is really applicable and it's valid for maybe a broader scenario or a broader number of applications of your system. And of course, do not forget the person evaluating it in heuristic evaluation should not be the developer or designer, as I have hinted at many times already, because those people are bad evaluators since they are so much concerned with this particular system design. Let's now talk about the cognitive walkthrough as another example of an analytical evaluation methods involving experts, not formal models. The idea is here, again, to have an inspection of a system or prototype which is based on some prescribed forms, basically. So it's a form-based inspection of system or a prototype. And the idea is the following. Designers present an aspect of the design plus some usage scenarios. So you see that fits pretty well to the scenario-based design method. And the expert knows who is evaluating that by going through that system usage in their mind, by knowing about the context. So they know about the user population, the usage context, the task details, so they have everything to actually imagine how this system would be used in a particular situation. And then you select a couple of tasks and go through these tasks in mind and imagine, if I wanted to maybe write this text, or if I wanted to change the color of a picture, how would I proceed given the current interface? That's the idea. And then you answer questions in that form here after each step. That's the idea. And they also note problems, the experts, while they walk through the problem. And such a checklist approach or form-based approach is of course attractive to practitioners who do not have much time. They just go through that, they just imagine this could be maybe a task A or B, and then they go through that and fill in this checklist. These approaches, or this approach of cognitive walkthrough, which was developed in 1992 by Paulson and colleagues, focuses on the ease of learning. So it's very good to evaluate cognitively before they have been built. Walk up and use systems such as an ATM, ticket machines, museum exhibits, etc. So because you can imagine, how would a person in this given situation maybe step up to this machine, to this exhibit, and how would they use it, for example, buying some ticket or so. So it's a very good way to imagine how a system would be used in a particular context. And the experts are thereby guided by 3 questions. And one is, will the correct action be sufficiently evident to the user? It has to do with the current state of the system and the options. Are they visible to the user? So this is very much a question which should be answered well in information design. Will the user notice that the correct action is available? It is very related to that. So will they get enough hints that they know, yes, I can now do this step, the next step? And will the user associate and interpret the response from the action correctly? Again, this is about the feedback then given by the system, most of all, or something which is opening or closing, or a cursor changing its shape because when it takes longer or so. And all these feedbacks are given to a user during an action. Here I show you an excerpt from a cognitive walkthrough form. It's like this, like step B, choosing the next correct action. Correct action, describe the action that the user should take at this step. So this is B1, and B2 is a knowledge checkpoint. If you have assumed user knowledge or experience, update the user assumption form. This is something like, the user should now maybe use the mouse to select a text fragment. Knowledge checkpoint, does it assume any previous knowledge of the user? Yeah, it would be just assume the user is able to position a cursor and to click on a button and to drag it and to release it. That would be the assumption you make here. And then, of course, it goes on like that and until, say, B5.a, some identifier location, some wording or meaning or type. So is there an identifier such as a menu entry or such as a text in addition to an icon you are clicking on? No identifier is provided. If there is one, what is the label? What is the wording? Is it a prompt? Is it a description or anything other? And is the location obvious or not? And you would find out that maybe you used a wrong text, for example, a wrong wording, or you find out that the description after an error has occurred is a bit lousy and doesn't provide much detail. Alright, and the variant of this cognitive walkthrough is the pluralistic walkthrough introduced by Byers in 1994. It's not performed by a single person, so the cognitive walkthrough can be done by a single person, but here it's a carefully managed team. That means some experts assemble as a team, start evaluating a system separately first of all, and then they engage in a managed discussion about their findings that lead to agreed decisions. That's very important. So the idea is to bundle the forces, to put together the cognitive power of some experts who walked just by their mind through a system, and then they talk about it. Is it a good wording or not? And they discuss it, which is good, and they agree on, they make decisions such as how to improve the wording in a particular situation. And this, of course, is a very well-suited approach if you think about participatory design, which is at the core of our scenario-based development approach, as you can imagine. So this is pluralistic walkthrough. And now let's come to a second group of the analytical evaluation method. So one was using experts' knowledge and using forms and using maybe questionnaires or guidelines to guide people, mostly experts, through the design of a system. And the second is a model-based or predictive analysis. That means this is a more formal part. For that, you build a predictive model of the system design. So that means you have some theoretical scientific work. For example, how would people maybe, how is their attention modeled? yeah, or their attention span. How would they possibly be able maybe to see something because you modeled maybe their peripheral vision, for example. So therefore it's not really practical, it's really based on some aspect of theoretical knowledge, which of course already hints at a drawback of these methods because they can only be used for parts which are well understood and modeled. So if, say, the attention span of a user is well understood and modeled, then of course you can use that formal model to evaluate a system. I give you another example. There are kind of human models for ergonomic usage to make ergonomic investigations or evaluations. Say you would like to investigate the reachability of a steering wheel in a car, and of course you can build the car and you can set a person like me into the driver's seat and then reach out and recognize, oh, it's a bit far, or I can't see anything because it's too high, the steering wheel or so. But of course this should not be done by hand, and it should not be find out only then when you have built the first prototype of the car. Instead, you use a figurine model, basically, not a wooden one, but an electronic one. So, and this electronic model can be used and can be, of course, varied, maybe in their size and whatever typical features what humans have. And then you do that, say, in virtual reality, and you measure whether they can reach the steering wheel just in a digital representation. That would be a model-based analysis. And if the model is even more formal, if it even includes, say, operation times, then you can predict something. So it's an idea. Of course, it's once you build the model, it's less expensive than user testing because you just pretend there is a user, and of course you can vary the potential user. Like with this model, you can be a large person, a small person, it can be thin, rather thick person, and that, of course, these variants can resemble a user group where you would maybe recruit some 1,000 or 2,000 users from a population carefully selected, and you just do that basically virtually. But of course, it's limited to systems with some predictable tasks where it is easy, such as the reachability of a steering wheel is something which you can really predict. Is it reachable or not? Or how far do you have to stretch maybe the hands or the arms to reach it? This can be figured out quite easily. Or you can also predict how long people take maybe to click on a certain sequence of buttons in a form-based interface. That is something you can figure out and predict, but it's of course not suited for a complex system, how it is operated. Then you definitely need real users to find that out. And of course, it's based on these models. These models are often based, not always, on an error-free behavior, so they have an ideal situation. Even, let's imagine this reachability of a steering wheel. The model, the virtual model, the figurine, basically sits in a car, and it does consider, okay, yes, it's reachable, but maybe the person is doing like this or so. And this is not modeled in your model, and then of course reachability is difficult. Or the person might scratch at their head, and is it still reachable or not? And all these things are not really well considered because it's just a formal description of people using a system and not actual people using a system. One classical example is beside these ergonomic models, figurine and men or women model, is the GOMS analysis. The GOMS analysis we talked about already. GOMS is goals, operators, methods, and selection rules. We talked about that when we talked about interaction design. So it's a state the user wants to achieve the goal, maybe to find something. Operators are the physical actions and cognitive processes which are required to attain that goal, to reach that goal. That means, for example, to decide which search engine to choose and maybe what to do, how to enter that. The methods are the actual procedures for accomplishing the goals. maybe dragging a mouse or typing in a certain edit box or so, or pressing a go button. And selection rules are not always necessary, as we talked about already, are rules where we can decide which method we would like to select. Either we go this way or we go that way. This example is the alarm clock we talked about. Of course, you can just increase the time to reach a certain alarm time, or you can decrease the time until you reach it back, for example. Of course, based on this GOMS analysis, since it is already a quite formal description of certain tasks and subtasks of a user interface, then we can build a predictive model using scientific knowledge about human memory and behavior. So it's a little bit like the hierarchical task analysis. So we can analyze for complexity, consistency, or build a computational version to estimate, for example, the task times for design alternatives. So if you focus on something measurable, such as time, this fits pretty well to this GOMS analysis, because you can imagine how long will it take, for example, to drag the mouse over a field, or how long will it take to press a button or to enter text. And you can use previously gained knowledge about such task completion times, for example. And if that is successful, it can provide a huge benefit. And why is it so? Because you can just imagine and predict that by arranging the buttons or the menu points or the other options, the widgets, user interface widgets in a dialog in that particular fashion, it saves time, or it does not save time. In a way, it extends the general technique of hierarchical task analysis. So in other words, the hierarchical task analysis in a way is also an analytical evaluation method, but you basically just evaluate how tasks are done in the real life or already with a previous version, say, of an interface or a situation, and of course not with the designed system. Because you have goals, sub-goals, and plans and actions, so this is very similar. But what is new here, and this is highlighted at this point, it is the mental activities play also a role. That means people also take some time to create their goals, or maybe to think about a selection, or to retrieve something from the memory, maybe a command they have to type in. And these components are considered in that model as well. Just again, a GOMS snippet. So this is maybe closing the active window, it would be the goal. And I have to make a selection between using either the menu method or the handle method or the control key. So for example, Apple W or Alt F4 in Windows would close the active window, and the use menu method would require you to move the mouse to the menu bar, to drag down the file menu, to read the on close, to release the on close option. Or you can use the icon or menu handle in the Windows border. So you move the mouse to this corner of a window, and then you click on the cross box, typically the red one with a cross or dot inside. So these are three alternatives, and each of them, of course, will cost you some time. It involves, say, moving the mouse or dragging down, finding also the cognitive action. I have to see 5 options. This is the one, and then I click on that, and this again costs time and of course some efforts basically. And to measure exactly how these times how long they are, there have been a method developed which we call the keystroke level model. So that means GOMS has also been developed to provide a quantitative model, so to be the basis basically for the keystroke level model, KLM. And the keystroke model allows predictions to be made about how long it takes an expert user, so it's not taking into account users who might not be as quick or who take longer to think about things, to perform a particular task. And the idea is simple. Every single task, like we have seen before, like moving the mouse from A to B, or like dragging down a menu, or like clicking on an icon, takes some time. And these times can be pre-assigned and they can be measured. Say you would like to, the operator would be pressing a single key or button. Yeah. So how long does it take to press a button? It takes maybe 0.2 seconds for an average skilled typist. Or for a non-skilled typist, it might take a little bit longer, almost 300 milliseconds. Or pressing the shift or control key, how long does that take? Etc. So you can have certain predicted values which can be of course measured. You can let people just type a text, an average text, and then you divide it by the number of keys they have typed, and then you come up with these measures basically. Or pointing can be of course derived from Fitts' law, which we came across when we talked about interaction design already. And then, of course, you have some mental preparation or response time. So you have to think about things like, for 1 second, I have to prepare over 1 hour. So what am I saying? Okay. And I then can now press on that. And that kind of table gives us the opportunity to simply add for the sub-actions you have described here with the GOMS model, to simply add all the different times, and then you come up with a predicted task completion time for a given task, say in a form-based menu. As you can imagine, this keystroke level model of course has lots of limitations because it is very much dedicated to interfaces where each action is actually measurable, and it's, for example, if I would do some gesture-based interface, or even if I have a speech input, yeah, for example, so everything which is more natural in natural user interfaces, it's more difficult because, as the name already said, keystroke level model is rather of things which are about things which are easy to measure, such as particular keystrokes, and therefore the predictive power of such a model is in fact rather limited, to be honest. Altogether, what are benefits and drawbacks of expert reviews? So experts tend to find different problems in an interface. That's good. And as we said, some 3 to 5 or maybe maximum 6 experts are already good to find most of the built-in usability problems. And another thing, however, to consider is that first of course, the experts do not actually use the system. That means they just pretend to use it, just think about it. So therefore, they are not really involved into a workflow activity. And in particular, experts is always usually referring to usability experts and not to domain experts such as medicine or ticket selling or travel agency or whatever we use as an example. That means they don't have an adequate understanding of the task domain nor of the user communities basically. And even experienced experts have great difficulty knowing how typical users, especially novices, will really behave. So it's really hard to imagine that people maybe not even cannot really not even easily move the mouse around, maybe as a first-time user like elderly people or so. Then of course it's a problem which you as an expert cannot really imagine anymore. Usability inspections are, as we said, rapid and cheap. These are certainly advantages, but of course you miss out details which would occur and problems during realistic usage. That's for sure. The model-based approaches, on the other hand, they have a very good scientific foundations. There are models such as ACT-R or keystroke model, keystroke level model, for example. So they are quite credible and can be very powerful, but they are also limited, as I just said, in their scope, what they can figure out and what you can really predict with them. So they, of course, to model, to actually build this kind of model or to find out all these different times, this takes a lot of time and expertise. And these are just a few examples. Again, GOMS, keystroke level model, Fitts law, which only predict experts, error-free performance, but the real life is different. So people, for example, they just are distracted for a second or so, or they're just, oh, what am I doing here? And already now this doesn't really work anymore, the prediction. So you can imagine that. All right, with that, I talked about this entire group of analytical models, which are quite powerful and should always, that's a statement, be combined with any kind of user interface development and design. And the empirical evaluation methods, which are of course also very powerful, even more powerful as we will see in a minute, they are involving real users, which is a big difference and of course also an advantage. But they take more effort. So I will talk about that in the next video segment. See you then.